SpaceX and Tesla, is set to launch the biggest rocket in the world today.
You are looking at a live view of the Falcon Heavy, the world's most powerful operational rocket by a factor of 2. And today is the day that we attempt to demonstrate that power.
Break through Earth's gravitational pull and head for a solar orbit, including Mars. This reported $90 billion mission paid for by billionaire SpaceX founder Elon Musk.
This is a point in history that we don't come to often. We're in this amazing transition point that we have not been in since the moon landings.
And a good luck to land. That's one small step for man, one giant leap for mankind.
With companies like SpaceX, we have alignment of so many capabilities and opportunities and changes happening that are all pushing in one direction, which is towards Mars.
We had plans to land the first humans on Mars in 1981 and have a permanent base on Mars by the late 1980s. And if anybody had told me when I was 17 watching that moon landing that I would be 64 and we wouldn't be on Mars, I would have thought they were crazy.
Apollo was, nearly 50 years ago. That's insane that we went to the moon with 1960s technology and haven't gone back since.
The question is, why did we not keep going?
Going to Mars is really expensive. It's such a massive human undertaking. We need commercial space companies that I think are going to help bring the cost of space down to open the frontier irreversibly for everybody.
Please join me in welcoming Elon Musk.
What we want to try to achieve here is to make Mars seem possible, make it seem as though it's something that we can do in our lifetimes, and that you can go. That's what we want.
We need to go to Mars because it protects us from extinction. There's all sorts of things that could happen on Earth that kill all humans on the planet. But once humans are on 2 different planets, the odds of extinction drop to nearly 0.
We're currently at T-minus 17 minutes, 40 seconds and counting down. All systems are go for launch with the SpaceX test flight of the Falcon Heavy launch vehicle.
This window of opportunity is open for life to go beyond Earth. But who knows how long that window will be open? Good. The tanks are fully loaded. Good. I hope.
Long as they don't blow up.
That's what the guy from SpaceX said. As long as they don't blow up, we're good to go.
This kind of thing can barely be done by extremely advanced governments.
T-minus 30 seconds.
And here comes a guy with $350 million who says, I'm going to start a rocket company and I'm going to get us to Mars.
SpaceX, Falcon Heavy, go for launch.
Humans cannot survive on Earth indefinitely.
Falcon Heavy is on internal power.
Yeah, it's ready to launch.
So think of everything that we've achieved as a civilization.
Falcon Heavy is a startup.
Think of everything that we've achieved as a culture.
T-minus 15, stay away from total count.
We will go extinct if we do not become a spacefaring species. Survival for humanity in the long run depends on it.
This is solid ground. It's called Launchpad 39A, and it's the place that the first humans left Earth and went to another heavenly body. So this is, I think it's the greatest launch site on Earth.
Buzz Aldrin, Mike Collins, Neil Armstrong, get into the transfer van to pad 39A.
Pad 39A was used for the Apollo 11 mission, and then with the space shuttle, so it's a place with incredible historical significance. Now, NASA has given launch pad 39A to SpaceX to use. All right, guys, we're going to go up the elevator. This is the launch tower. So this is where the astronauts would go up. And then there would be a big arm that would swing over to the spacecraft. And they'd walk down the gangway, climb in the spacecraft, go to space. So this isn't floors, this is feet. Very cool.
From the first explorers who ventured off our planet, to those who have risked their lives in pursuit of furthering our understanding of the universe, the astronauts and engineers behind the U.S. space program have spent decades advancing space technology. But building rockets was expensive. By the early 2000s, the U.S. space program was struggling, and a mission to Mars was hard to imagine.
The space shuttle spreads its wings one final time for the start of a sentimental journey into history.
It was then that a young entrepreneur had a revolutionary idea.
With SpaceX, what we're trying to do is achieve a huge advancement in rocket technology. If you look at rocket technology, it actually got worse over time. In 1969, we were able to go to the moon. And then with the space shuttle, we were only able to go to low Earth orbit. And then the space shuttle went away, and then we weren't able to go to orbit from the United States. See, like, that's a negative trend line. It's not like you can extrapolate that trend line into the future and it gets good. It's a trend line to zero. So if it's not going to come from the government, then it's got to come from a private company. So Falcon Heavy ended up being a much more complex program than we thought. Well, we're super excited, obviously, at SpaceX to announce some of the details around the Falcon Heavy rocket, which is our large rocket development, really large rocket development.
Falcon Heavy is the most powerful operational rocket in the world. In addition to the center core, it's powered by 2 Falcon 9 rocket boosters that have each flown and landed once before. They'll now be reused to launch Heavy.
Falcon Heavy is really a revolution in space technology. The long-term goal of SpaceX is to develop the technology necessary to establish a self-sustaining city on Mars.
One of the most exciting parts of working in SpaceX is missions like Falcon Heavy. These bold missions, these bold visions for just doing things better, but also doing things on a much grander scale.
Alright guys, let's go ahead and get this pre-task going for dance floor removal. It's going to be the first time that we do it. So here's number 1 rule. We're going to take our time and be safe. So I want everyone to walk through, make sure the area is clean. We're not going to have access to those areas once the dance floor is out. So let's do a pod sweep and then we can get into it.
There are things in your life that you will remember, you know, the birth of your kids, and then when we landed a rocket here, and this one will be another one for sure. The fact that we built and we're launching the largest vehicle since Saturn V, the rocket that took us to the moon. Folks will look back on Heavy as a stepping stone to Mars.
Liftoff. We have a liftoff.
Werner von Braun, who built the Saturn V, overbuilt entirely the rocket to go to the moon.
Saturn V is the largest, longest, and heaviest machine ever built by humans. It's absolute overkill for going to the moon. And the reason is, von Braun didn't want to go to the moon. He wanted to go to Mars. Von Braun, just like Elon Musk, was intensely aware that humans, in order to survive, have to become a spacefaring species.
Mars is the only possibility in our solar system for being multiplanetary with the technology that we're aware of right now.
Main engine start, 0, and liftoff of the Atlas V with Curiosity.
Great news this morning. The NASA Mars rover Curiosity touched down this morning right there on the red planet.
Shot confirmed. Proceed.
Spirit, Opportunity, Curiosity, all of these rovers have started to unveil and show us that there is water, that the Martian soil has nutrients.
Mars is the closest planetary object that has all the conditions and resources needed to support life and therefore technological civilization. We just have to get there.
Before we do the flight, we do what's called a static fire. So we will load up the propellants and start the engines, but hold the rocket down to see if there's anything that seems suspicious to us.
Last interesting is that the weather is pretty favorable, okay? Primarily in winds, above 25 miles per hour.
And assuming that all the manual checks and the automatic checks come back okay, then the rocket will be released for launch. All felt heavy. We're into like 27 engines simultaneously, so there's a lot that could go wrong.
So 5 hertz is where we really go. 5 hertz is where we're likely, just in that territory.
Yeah.
Stay out of it. Yeah.
The static fire lets you make sure the rocket's healthy, the pad is ready to go. That's also a time when you can find some really significant surprises. Some are good, some aren't so good.
AGS, we've been having some conversations with automation. It seems like 5 hertz is a hard limit in terms of operation of that auto engine. If you see this thing coming down towards 6.5 or 6 hertz, I think you should be calling our attention to it.
We're pretty gun-shy about launching. If we see anything that seems questionable, we don't launch.
Briefing for instructions for on board. In the need for an urgent abort, operator shall call hold on the primary countdown head.
That results in a lot of postponements.
Rails full of and the cylinders are retracting. Tarmac secure for T0, 88.3 degrees. Gas closeouts have started. Hold on countdown 1, go for static fire. Reminder, Cyclo's transit startup is at T-minus 7 seconds.
Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Full duration, static fire. Static fire was a pretty big deal because even though there was a successful static fire attempt, honestly, it is a brand new vehicle.
Falcon Heavy is the culmination of years of innovation in rocket technology, taking the company one step closer to Mars.
It's going to be exceptionally difficult to go to Mars. You're talking about, new technologies in virtually every possible system. And this is where, science and science fiction sort of collide in a way that is helpful. You learn a lot more, but it also reminds you of just how much there is at stake.
2, 1.
There is no such thing as a perfect record in rocketry. On average, 20% of all attempts to get off the face of the Earth with a rocket fail.
there's a strange relationship between failure, risk, and innovation, which is you can take risks, you can try something very innovative, but you're more likely to fail. This is why different types of rocket companies and NASA itself tend to go with older technologies.
I first met Elon back in 2000, and I was actually trying to talk him out of doing SpaceX. I said, look at all of these dead bodies along the way, you know, all of these companies that have attempted to go, I mean, come on, what are the odds you're going to succeed? But he's shown the world it's doable.
Falcon Heavy has been 7 years in the making, but it all started with SpaceX's first model, Falcon 1. This was their first attempt to create a reliable, low-cost rocket made up of 2 stages and designed to reach low Earth orbit.
Rockets, they really don't want to work. They like to blow up a lot.
3, 2, 1, 0, +1, +2, +3,
At the beginning of SpaceX, I originally thought, okay, I got enough money for 3 attempts. In sequence initially.
3, 2, 1.
And we unfortunately we did have 3 failures. Well, failure sucks. It's really terrible. There's 1,000 ways that a rocket could fail and 1 way that it could succeed. Particularly in the beginning, it tends to fail more than succeed. But we managed to scrape together enough to have a 4th attempt.
3, 2, 1, 0. We're stage 1.
Thankfully, that 4th attempt worked. This is just the first step of many, and this really opens the way for us to get Falcon 9 going, get manned space flight, and ultimately getting to Mars. I mean, there's so many cool things that are there in the future. I think that this is definitely the future of SpaceX is really great. I mean, this is.
When Elon Musk decided, I'm going to go off and build my own rocket company, everyone thought he was crazy, everyone laughed.
No one has ever really contemplated this in a serious way. In the beginning, we thought, this is so crazy, what are we doing trying to come up with something like this? And then over time, we're like, yeah, it can definitely be done. And now we're just kind of arguing over details.
We can explore the universe. We can put a colony on Mars. People can be interplanetary. And it's just an engineering problem like any other. It just takes a group of people who care a lot and are happy to work really hard to make that happen.
So the long-term goal is how fast can we establish a self-sustaining city on Mars?
Do we focus on just trying to get the ship there and then maybe some people some other time?
I think we'd send the ship, make sure it can land okay. Assuming that lands okay and it seems to be working, on the next Mars mission we would send people and additional equipment.
SpaceX is like no other rocket company. They're in an unglamorous building, in the middle of nowhere, in kind of an industrial zone. But when you walk into the doors and all of a sudden you see they're making these pristine, gorgeous rockets, it feels like you've walked into a factory on another planet.
After Falcon 1, SpaceX set its sights on the next phase in their rocket evolution, the Falcon 9. The design called for a booster which contained 9 Merlin engines and increased the amount it could lift by more than 30 times. But the key component of the Falcon 9 design was reusability.
SpaceX Falcon 9 and Dragon go for launch.
Elon Musk has said the key to get to Mars is the reusability of rockets.
LCLD, go for launch.
That's an extremely complicated concept. He wants to be able to fire a rocket into orbit, launch a payload into space, and then fire retro rockets and bring that rocket down to land vertically and reuse it. If he cannot make rockets truly reusable, then he cannot launch a new civilization on Mars. So SpaceX has an incredible camera focused on it, an incredible amount of attention. Because it's the only company in the world that is actually trying to do what it's trying to do, which is develop the technology to get humans to Mars. Civilization on Earth is actually very vulnerable.
Either we're going to become a multi-planet species and a space-faring civilization, or we're going to be stuck on one planet until some eventual extinction event.
Lots of rockets fail all the time. The only time anybody ever notices is when a SpaceX rocket fails.
That was June 28, 2015. Actually my birthday. Normally I'm here for the missions, but going, okay, well, it's my birthday, so, and then, so that was a real downer. After that failure, obviously we needed to do a complete review of the whole rocket. So the whole launch program ground to a halt. We've been launching a rocket about every 6 weeks or so, and then we didn't launch a rocket for 6 months. And that put a lot of financial stress on the company. We had all the cost and none of the revenue.
One of the most radical ideas that SpaceX has to lower this horrendous cost of getting into space is reusability. It now costs $60 million every launch. Send up a satellite, the rocket gets destroyed, you've lost $60 million. If you can reuse that rocket 1,000 times, the cost goes from $60 million to $60,000.
The SES-10 mission features a Falcon 9 that had launched and landed once before. If successful, this would be an historic day for SpaceX, the first reflight of an orbital-class rocket.
We're going to try to launch our first reused rocket. This company was founded to make space more accessible, and the fundamental key in doing that is having a reusable rocket.
T-minus 10, 9. It's going to drop the cost of getting to Mars by a huge amount. To come back and land at the launch site and fly a game, just like aircraft. 1.
Liftoff of Falcon 9, the world's first reflight of a world-class rocket.
The cost of fuel and oxygen is very low compared to the cost of the rocket booster and the spaceship.
Imagine if you took a flight from New York to London, and then at the end of the flight, they threw away the plane. Imagine how much tickets would have to cost for that flight in order for the airline to make money. That's ridiculous. You reuse the plane.
I just don't think there's any way to have a self-sustaining Mars base without reusability. It's really fundamental. If wooden sailing ships in the old days were not reusable, I don't think the United States would exist. But reusability is a very hard problem because you've got to enter the atmosphere at an incredibly blazing fast speed. You got to fire the rockets into supersonic airstream, zero out your velocity, put landing gear, and land. And you go one shot.
The pressure is so high on this launch. These rockets are complicated machines, and we're doing something new. There's always uncertainty associated with that.
Right
right now we're just watching our screen here, and hopefully we'll all see a successful landing all together.
If they nail this ability to land a rocket from being in space on Earth, then they can nail doing it on Mars.
With the success of the SES-10 mission, SpaceX had all the ingredients to assemble the most powerful launch vehicle since Saturn V, the Falcon Heavy. Heavy has the ability to lift more than the weight of a 737 jet, loaded with passengers, crew, luggage, and fuel. With reusable boosters and an increased payload capacity, it's able to transport the incredible amount of supplies needed to build a human civilization on Mars.
After setting fire, we come back into the hangar, take the fairing off. We'll have a lot of inspections to do, we'll have a lot of data to review. With Heavy, since this launch is a test, there's a lot that we don't know about the vehicle yet. So we've done hundreds or thousands of tests of various systems, but until you put it all together, you don't really know what's going to happen.
There's really no commercially viable heavy lift vehicle out there today. Heavy has about twice the carrying capacity of the next biggest rocket that's out there. To have the world's largest rocket flying is really important. It means we can launch the larger payloads that are necessary for getting things to Mars as well.
Ultimately, any launch vehicle is intended to bring a payload to some sort of orbit.
As a test launch of a new rocket, the convention in the space industry is actually seem quite boring. Like, they'll literally launch a block of concrete. Why waste a good test launch on a block of concrete? It's the most fun thing that we could send to Mars orbit. The suggestion that everyone thought was the most exciting was to send a car through space. And then putting all sorts of interesting bits and pieces in the glove compartment, in the trunk, and we want to have big sign that says "Don't panic," from Hitchhiker's Guide to the Galaxy.
Once we get the go-ahead from all the responsible engineers saying that their systems are okay and that we've checked everything out, we will get the payload in, get everything buttoned up, and finally seal up the flight, bring it back out on the pad, go vertical again, and be ready for launch.
One note on that top bullet. So T-minus 30 seconds is when we're looking to get all decisions on the manual abort. And after that, we are pencils down. We're going to let the vehicle abort system abort us if something is truly wrong with the vehicle.
Today is kind of the final checks of the launch vehicle, making sure that the pad and launch vehicle are connected together, talking to each other, checking all the final systems and things like that, giving everyone an opportunity to voice their opinion about their readiness. And we have to go look at something, we'll go look at it, we'll go fix it.
There's so much that goes into preparing, because this was the first time this vehicle's ever been put together. So the center core and the second stage and the fairing are brand new, but the side cores are actually boosters that have flown before. I can't remember how long it's been since everybody's felt this nervous and so electric about something. Because the last thing we want is to just rush into a disaster.
These types of complicated missions require large teams of differently skilled people to work together to accomplish something.
Okay, overall status on work orders tracking very well. Really impressive by that entire team.
You need people with skills in a lot of different areas, with expertise in different areas. But if you have these big teams of experts, the impossible really becomes possible.
And LG, sorry, one additional question about wins. It sounds like we'll be fairly close to the limits, but still, if
things play out tomorrow as expected, we'll be on the good side.
That's right. If there is a part of the window that is favorable, he had to assess the whole 2.5-hour window to give his 20%.
Okay. Falcon Heavy is a more complicated machine, it's a bigger machine, it's harder to analyze, and there's more folks that have to be involved to understand how it's going to perform. As we go through the challenges, we run into problems. I'm very thankful for the early days for SpaceX and for launching rockets. When Ricky Lim and I were in the Marshall Islands and we were on quads launching Falcon 1, we've had 10 years of launching rockets together and working through many, many challenges. And over the years, from Falcon 1 to Falcon 9 to Dragon missions, each one of these has been a step that allows us to test out and to build technology that will eventually allow us to go to Mars. And Falcon Heavy is a next critical step in the evolution of how we're going to develop the Mars program.
Now, after almost a decade of work, there are just 24 hours to go before Falcon Heavy attempts its maiden flight.
Elon, in our lifetimes, where will SpaceX take us, or where will humans go to space?
I'm very hopeful that humanity will have a base on the moon and a city on Mars in our lifetimes.
In our lifetimes?
Yes. Yes. Hopefully Falcon Heavy will inspire people to think about Mars. Because, there's all these defensive reasons of, like, we want to be a multi-planet species and having a life insurance policy in case something bad happens to Earth. But I personally don't find that nearly as motivating as the excitement of being a spacefaring civilization and being a multi-planet species, getting out there among the stars and seeing what the universe is all about. But I find it incredibly inspiring.
Vous savez qu'on est actuellement en train de passer sur les canaux SpaceX, je ne sais pas. Salut, on fait des bisous.
And when I talk to other people, I also find it inspiring.
Two scientists are going to spin off right here. The third one is going to continue going in orbit.
In Apollo, when people landed on the moon for the first time, that was something that was great for all of humanity. And there were people that walked 50 miles to find the one TV where they could see the thing. What do you think about the moon landing?
Well, it's the beginning of a new frontier, gateway to Mars.
So, whether you're rich or poor, whatever country you're in, everyone needs inspiration.
The number of people that came out and traveled a really far distance, coming across the country in certain cases, and to actually see the public be that interested in what we're doing, it's pretty amazing.
Elon Musk calls this rocket Falcon Heavy, the biggest rocket to take off from here since the Apollo moon mission. Very well changed the face of space.
ความสำเร็จครั้งสำคัญของ SpaceX นั้นไม่เพียงแต่พลิกโฉมหน้าของการ
Today's mission is all about the mantra, go big or go home.
Heavy lift capability is the critical technology needed to enable human missions to Mars, and a reusable heavy lift vehicle is the critical technology needed to settle Mars.
If Heavy works, it's an even better rocket than Falcon 9 because it can deliver more payload and sending stuff to Mars. Heavy is really the vehicle you need for that.
Getting to Mars will be risky, dangerous, uncomfortable, but it'll be the greatest adventure ever in human history.
Is that yes, you there with you. Do you see the picture of the section? Yeah, just send it over here. So weather officer is telling us that the trend's better. Okay. Towards the end, so we're thinking the recommendation of going to the end of the window. That's pretty wide. It's 55 minutes.
So we're at 3:05 p.m. T0 right now, and we have until 4 p.m.
So if you look at that picture, the dark blue line is the latest line,
I'm prepared. This is training the positive and negative. That suspect whether we postpone one or not.
So you guys are going to give us a little bit more time to decide. Just going to push the clock.
I don't get hold the clock for now.
You got it.
What is the soonest we can launch?
As soon as we can launch, we have 90-minute propellant load at T-minus 85 minutes. That's the point of no return. We'll start to make a detailed concept. That's right, yeah.
Launch day is easily the most nerve-wracking day ever. Every launch, every mission, we want to go perfectly, but the last couple of hours, everyone's just looking out for things that can get in the way and just removing blockers. So I would like to give as many options as possible. I just want to get the required items going now.
Okay, all right, by the way.
You got so 345 local, give you options. All right, very good. All right, he still needs a little more time. We're going to get the clock rolling. 3:45 p.m. local, and then give him some more time.
The window for the SpaceX liftoff is quickly closing down.
They have heavy winds at altitude, and the wind shear at altitude could affect the trajectory of the rockets.
Stage 2 loss load, throttle back.
There's a lot of risk in play. There's a lot that could go wrong. This is the wind speed. This is altitude. So looks like the rocket's going straight. But it's not. The rocket's like rising, and then it gets hit by a jackhammer. They never run it out. That can cause the rocket to snap down.
Stage 2 loss load.
So about halfway through the first stage's burn, the two side boosters will separate and come back to Earth for a simultaneous landing and executing a 3-burn maneuver to get them back to landing zones 1 and 2 and Cape Canaveral Air Force Station. Now this second stage, with the fairing right at the very top there, that second stage will be sending our payload way out into a Mars crossing orbit. So if all goes well after launch, we'll have 3 first stage cores back on Earth, 2 for the second time, and a wealth of data for perfecting airplane-like operation in the future.
T-minus 10 minutes. Falcon Heavy is on internal power.
Okay, everything's green, guys. Full system's green. Okay, party time. Good. I hope.
EMTS is ready for launch.
Falcon Heavy is in startup.
Yeah, this image. Just a giant explosion on the pad with that wheel bouncing down the road. And side boosters landing somewhere with a thud. Well, Falcon Heavy. We're going to light 27 engines simultaneously. This is an incredible amount of force and noise and vibration and heat. We will do our best to minimize the risk associated with it, but it's a test flight. And take that thing, I hope it doesn't, touch wood, but that thing could blow up on the pad.
SpaceX, Falcon Heavy, go for launch.
Falcon Heavy is on internal power.
EMTS is ready for launch.
Falcon Heavy is in startup.
Okay, so what we do is, let's off, we run outside and we're still. Actually, give it 10 seconds, because we're able to see it. And then about 10 seconds from that, after we see this thing go, we'll run out.
T-minus 30 seconds.
Launch director on countdown 1. SpaceX, Falcon Heavy, go for launch.
Falcon Heavy is configured for flight.
T-minus 15, stand by for terminal count.
If one of those engines fails, it will trigger an abort. All systems are currently green.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Lift off. Go. Off the pad.
sightings on guard, also good.
On your screen at the moment, you've got a few things happening. On the upper right, you've got MVAC-D continuing its burn, and the two bottom screens, you've got the side boosters headed back towards Cape Canaveral Air Force Station, landing zones 1 and 2.
Both side boosters transonic.
Guys, do you see there's like a car in space? You guys have been in that car. I've driven you in that car. This is so fruity.
We want to demonstrate that Falcon Heavy is capable of getting to Mars orbit. If it's like out there floating for millions or maybe a billion years, and then maybe long after human civilization is maybe gone, maybe some future ancient civilization will come around and find it and say, hey, this is cool, look what those guys are up to. It's one of those things that's a reason to live. Life can't just be about solving one miserable problem after another. They have to be reasons that when you wake up in the morning, you look forward to being alive. You're excited about the future. That's, I think, what Mars represents most to me. It's seeing what the universe is all about.